Alright everybody, let's see how to solve example number 3. Now example number 3 is saying that water at 50 degrees Celsius inside a tube flows that has a conductive heat transfer coefficient of 3500 watt per meter squared degree Celsius. The tube has a thickness of 0.8 mm with a thermal conductivity of 16 watt per meter degree Celsius. The outside of the tube loses heat by free convection and the heat transfer coefficient is 7.6 watt per meter squared degree Celsius. So the question is asking us to calculate the overall heat transfer coefficient and also the heat transfer, the heat flux to the surrounding air at 20 degrees Celsius based on the outside surface area of the tube. So the question is asking us to calculate the value of UO, U outside. So before we start to solve this question, let us draw and label all the information that we have. So we have a tube, and then the tube has a thickness of 0.8 mm, so we can say that this is the thickness of the tube, and the tube, water is flowing inside the tube. Okay, hot water. So the temperature of the water is T equal to 50 degrees Celsius, and then on the outside air is flowing at the temperature of T equal to 20 degrees Celsius. So we know the diameter of the tube. Okay, the diameter of the tube, the inside diameter. So let's say this is the point. So this is the inside diameter. So di. Okay, di is equal to 0.025 meter. And then we have the thermal conductivity of the pipe is Km is equal to 16 watt per meter degree Celsius. The thermal conductivity of the water inside Hi is equal to 3500 watt per meter squared degree Celsius, and our H of air flowing on the outside, the HO outside is equal to 7.6 watt per meter squared degree Celsius, and then the thickness of the wall XW is equal to 0.8 mm. Okay, so now we want to find the value of UO. In order for us to find the value of UO, we'll be using this equation. Alright, UO is equal to 1 over Hi dO over di plus XW over Km dO over dL plus 1 over HO. So this is the equation that we will use. So if you look at the information that we have and the equation, there are still few informations that we don't have. First of all, we still don't know what is the value of DO. So DO, and then we don't know what is the value of DL. So first, let us see how to calculate the value of DO. Now remember, we say that the thickness is given to us as 8 mm. So to find value of DO is equal to di plus 2xw. This is the general equation. Why we say? Because we know that DO, our di is from this point to this point, this whole thing is di, and DO is from this point up to this point. So we know that this is our di and this one is our thickness xw, and this is also a thickness. So that's why in order for us to calculate the value of DO is DI, this one to this one, plus 2 times xw. This is the first xw, this is the second xw. So by using this equation, we'll get the value of DO is equal to 0.0266 meter, because 0.8 times 2 is 0.16. So this is how you get the value of DO. Now to get the value of DL, which is our log mean diameter, we already know the equation, DO minus DI over ln DO over DI. So you'll get a value of DL is equal to 0.0258 meter. So now if you look at the information that we have with the equation, we have all the information. We know our HI value, we know our DO value, DI value is known, XW is known, KM is known, DO is known, DI is known, and HO is known. So now we can just substitute all the values into the equation and we can find the value of UO. So I would prefer if we do it one term at a time, meaning that the whole equation we know. So let's take out the first term, because in this equation we have 3 terms. The first term is 1 over HI DO over DI. So this is the first term. So if you put the value, you get 1 divided, so the value of HI is 3500 watt meter squared degree Celsius. The value of DO 0.0266 meter, and the value of DI is 0.025 meter. So cancel out the units, meter, so you still have the unit of meter squared degree Celsius or watt. And if we put in the calculator, you will get a value of 3.04 10 to the power of -4 meter squared degree Celsius over watt. So we do the same thing for the second term, which is XW over KM times DO over DL. So we'll get a value of, this is the equation, this is all the terms. So XW is 0.8 mm, or also 0.8 times 10 to the power of -3 meter, because milli is equal to -3, divided with the value of K is 16 watt per meter squared degree Celsius, and then times with our DO over DL, which is 0.0266 meter divided with 0.0258 meters. So again, cancel out the units. So you'll have a unit of meter squared degree Celsius over watt. So the value is going to be 5.155 10 to the power of -5 meter squared degree Celsius over watt. And then the final term is 1 over HO. So it's going to be 1 over HO is 1 over 7.6 watt meter squared degree Celsius. So you get a value of 0.1316 meter squared degree Celsius over watt. So now you know the value of each of the term. So we can just substitute all this value into our UO equation, and we get the value of UO. So again, one more time, UO is equal to 1 over, the first value is 3.04 10 to the power of negative 4 plus the second term was 5.155 10 to the power of negative 5 plus the third term was 0.1316. Substitute, put in your calculator, you'll get a value of UO is equal to 7.58 watt per meter squared degree Celsius. So this is the answer for the first part of the question. The second part of the question is asking us to calculate the value of heat flux. So remember, when we say heat flux, the unit is going to be watt per meter squared. So to calculate the value of heat flux, we have the general equation dQ over dA is equal to U delta T. Okay, so if you want to find the heat flux based on the outside surface area, so we can just put here dQ based on the outside surface area. If this is on the outside surface area, and then we must also put UO. So to find this value, we already know the calculated the value of UO. So it's 7.58 watt meter squared degree Celsius times with the value of your delta T. So delta T is going to be temperature on the inside minus temperature on the outside. So 50 minus 20 degree Celsius. So if you do unit cancellation, degree Celsius minus degree Celsius, the unit left is watt per meter squared. So the answer is going to be 227.4 watt per meter squared. That is the answer for your heat flux.